power of mathematical thinking gives you certain qualities. The first one being mathematical abstraction. By bringing abstraction, we give importance to a larger message rather than the specific one. For example, in the context of propositional logic, we were discussing propositions such as 2 plus 3 equals 5 and x plus y equals z, and we were discussing statements like this: today is Monday and 2 plus 7 is say 100. We saw that some of them, they depend on the context, so we said such statements we don't want. A declarative statement taking true is considered to be a proposition. A declarative statement taking the truth value false is considered to be a proposition. So essentially it is a declarative statement taking the truth value true or false. The statements which are not propositions we don't consider. Okay, although it is declarative, but it depends on the context. If it is on a Monday, it is true. If it is on some other day, it is false. And for some values of x, y, z, it is true. For others, it is false. Correct? And these two are dependent on the context, so we don't consider, because our definition of proposition is independent of the context. So we look at propositions of this type. And you can talk about other statements, propositions as well, but a larger message is we are not focusing on statement like this. Instead, we want to bring in abstraction. So we talk about something called propositional variables. So we use letters P, Q, R to denote propositional variables. Most importantly, we are interested in the focus is on what the truth value of these propositional variables. And expressions involving PQR. So when we talk about expressions, naturally you need to bring in something more. What is that? That's called logical operators. With the help of logical operators, we combine propositions. We have propositional variables P, Q, R, and then with the help of propositional operators, we make a new proposition. Something like 2 plus 3 equals 5 or 2 plus 7 equals 100. And suppose you say today is holiday and today is Monday. So you make statements like that, and as long as both are propositions, then you talk about combining them. So we talk about operators, logical R, logical AND. Then we also talk about exclusive OR. Then we talk about something called conditional operator. Then something called biconditional operator. So given P and Q, the proposition P or Q is denoted using the notation P or Q. Similarly, you have P, logical and Q, we use this notation. And we say P conditional Q, conditional operator, which is P implies Q. We talk about P biconditional Q, and the operator is this. So variant of R is exclusive R, which we denote using this symbol. We also have a unary operator called negation, so which is denoted using this symbol. This is not P, or negation of P. So what we will do is, if you assume P takes the value true and Q takes the value true, what is the truth value of the expression P or Q? In general, what possible values that these proportional variables, namely P and Q, can take, and for each of them you look at what is the truth value of P or Q, what is the truth value of P and Q, what is the truth value of P or Q, and so on. As we mentioned before, when you look at the truth value of an argument consisting of sequence of paragraphs, in turn each paragraph consisting of a sequence of logical statements. First level is abstraction. When we do abstraction, the paragraph containing sequence of logical statements is converted into sequence of proportional variables P, Q, R, and so on. Then we look at the paragraph again. We see whether are there logical operators involved in combining these variables. If the paragraph may be, the first statement in the paragraph may be P or Q, and second statement in the paragraph may be Q implies R, third statement in the paragraph may be R exclusive or S, and fourth statement may be negation S. With that, we may conclude saying P implies yes. So this is given to us. At the end of the paragraph, you see that therefore P conditional yes. Appropriate statement for P, appropriate proportion for S. So essentially, an argument which is given in a natural language like English is converted into an expression in first order logic. This is what we call it as first level abstraction. And now the focus is on the truth value of the argument. We make a statement, we make an argument, and that argument is indeed conveying the intended meaning when there is a truth value associated it. And if it takes the value true, then we say yes, it makes sense, there is a logic in it, and we start accepting, and we may start using the conclusion of that argument in a different argument. So for such purpose, we want to know what is the truth value associated with the argument. Is P implies yes follow from the given premise, given argument? Given this, does this imply P implies yes? So we make statements like other day we were discussing that all prime numbers n greater than or equal to 3 are odd numbers. Some odd numbers are multiple of 5. Therefore, some prime numbers are multiple of 5. And so that's the conclusion. So if you translate that into an expression involving proportional variables, we are interested in knowing the statement or the conclusion some prime numbers are multiples of 5, does it follow from the given argument. So what we will do is, that's the kind of example or case study we are interested in as part of this course. So this course teaches you that we don't give importance to prime numbers or odd numbers. Instead, we extract the essence and a larger message is given to you. Since the larger message is across you, you can start looking at the underlying message and start applying logical operators, logical implication, identities, which we shall be discussing now in the context you come across. The context may be from a database management system, it may be from an operating system, maybe from data mining. And when you see there is logic in it, meaning the argument is conveying truth value true, you start using in your research. You start using that as part of some other problem. You start using that when you start modeling some other problem, reducing one problem to some other problem, and so on. So now what we will do is, looking at these operators, we shall discuss the truth value of each of these expressions. Then we will take a couple of examples and translate that into proportional variables, proportional expressions. Then we make use of the truth tables that we shall be discussing now to assess the truth value of a given argument.